The Dynamic Learning Maps Alternate Assessment System is a new assessment designed to more validly measure what students with significant cognitive disabilities know and can do. This presentation on properties of lines and angles is one of a series of training videos that support teachers of students with significant cognitive disabilities in their efforts to teach and assess more effectively. Sponsored by a grant from the U.S. Department of Education, Office of Special Education Programs, this training is part of the professional development efforts of the Dynamic Learning Maps Alternate Assessment Consortium. In other modules, we discuss students exploring geometric properties by sorting, comparing, identifying, and classifying two-dimensional shapes and three-dimensional figures. These learning experiences help students develop a deeper understanding of geometric properties. We want students to learn that shapes can be described as alike and different based on their geometric properties. This module will provide information specific to lines and angles so that you can continue to support students' understanding and learning of properties of shapes. Let's start with a discussion of lines. When students first experience lines, they do so in the context of simple shapes such as squares, rectangles, and triangles, and we tend to refer to them as sides of a shape. Students learn that shapes can have different numbers of sides, and they can be sorted using that attribute. When we begin the study of lines, teachers can create lessons that specifically relate the student's background knowledge of sides to the new vocabulary of lines and line segments. A line is a straight path of points that goes on in two directions. This horizon represents a line, as well as this line, which can be called line AB or BA. A point is an exact location in space. It can be a point on the tip of a pencil, or points on a page, or the points on a shape. The line segment is a straight path of points that has a clear starting and stopping point. This segment could be called line segment CD, and the shape you see here is made up of line segments AB, BC, DC, and AD. Just as we use a student's background knowledge of sides to learn about line segments, we can also tap into their background knowledge of measurement. By third grade, students have already experienced measuring and then sorting, comparing, identifying, and classifying objects and shapes based on those measurements. When students are learning about length measurement, we teach them that length is a characteristic of an object found by quantifying how far it is between the endpoints of an object. So when we begin the study of lines, we are going to provide lessons that connect this concept to the new vocabulary of lines and line segments. For example, when measuring the length of a desk, the edge has a clear starting and ending point. This is a line segment. Pairs of lines have specific names depending on their relationship. Parallel lines can be introduced informally in the beginning as two lines that run side by side in the same direction and remain the same distance apart. Finding examples of parallel lines in the classroom or the community helps students recognize and describe parallel lines. For example, the image of the railroad tracks that actually shows two sets of parallel lines: the rails themselves and the slats that are underneath the rails. The top and bottom edge of a bulletin board, the opposite sides of a book cover, the sides of a door frame, and the sides of a bookshelf. Here we have intersecting lines, which are two lines that pass through the same point. Intersecting lines can be found in the letter X and in this pattern of intersecting lines. Finally, we have perpendicular lines, which form square corners or right angles. Look at these two lines. You can see that where they meet forms right angles. And here we have line segment AB that is perpendicular to line segment CD. Pause for activity 1. Now let's shift our discussion to angles. Students start by recognizing angles in geometric shapes and understanding that when two lines meet, an angle is formed. Just like many other areas of math, angles can be compared to one another. Look at the angles represented here. Which is the larger angle? To this point in a student's mathematical learning, the emphasis has been on the length of measure, so a common misunderstanding is that the figure with the longest lines would have the largest angle. When we are teaching the concept of angles, we need to draw upon the student's prior knowledge of making comparisons by directing their attention to the new attribute, the space between the two lines. Officially, this is referred to as the amount of turn. Now the students can determine if the angle in figure A is larger or smaller than the angle in figure B. Once students begin comparing angles, we can also begin to introduce the language of angles. And just as a reminder, these words would not be a part of a student's core vocabulary. They will need to have receptive understanding of the words, and they may be used as fringe vocabulary for some mathematical activities. The names of the angles are acute, obtuse, and right angles. The essential elements require the students to recognize these angles. It does not require them to use the words expressively. Finally, students are expected to compare an angle to a right angle and describe the angle as greater than, less than, or congruent to a right angle. Pause for activity 2. There are several key points to think about as teachers plan for instruction. To start, geometric relationship refers to the connections that can be made between different categories of shapes. Students learn the properties that define a rectangle, a square, a quadrilateral, and other geometric shapes. As students' understanding of these properties develop, they learn that some categories of shapes are subsets of other categories. For example, they learn that rectangles are also quadrilaterals because rectangles have 4 sides. Squares are also rectangles because squares have 4 sides and 4 right angles. And rectangles are also parallelograms because rectangles have opposite sides that are parallel. Some students may struggle to fully comprehend and explain the relationships between categories of shapes. However, teachers need to be careful that they do not classify shapes rigidly and do not communicate misinformation that students will need to unlearn later. For example, it's inappropriate for a teacher to state, "No, that's not a rectangle, that is a square," because later they will have to learn that a square is a type of rectangle. Instead, we can say, "The name of this shape is a square, and we can tell because all 4 sides are the same length." When students have developed an understanding of the attributes for two-dimensional shapes, then they will be able to sort and identify the attributes that the shapes have in common. For more information about the Dynamic Learning Maps Alternate Assessment System, please go to www.dynamiclearningmaps.org. Thank you for your participation.